Welcome and hello. This is a video tutorial in HEC HMS, and in this lesson, we're going to discuss computing and viewing simulation results for optimization trials. All right, what I have on the screen here is a project that's been loaded up. I've got a watershed that's been delineated into three different subbasins here with an outlet at the west end of the watershed. Over here in the Watershed Explorer, I have my components, my compute tab, and my results. Over here in the compute tab, I want to point out I've got two different optimization trials that have been created. One is a maximum objective, and then the other is a minimum. We'll take a look at that a little bit later. In this video, we're going to do two things. First, we're going to run a optimization trial, and then after that, we're going to view the results, both on a basin-wide results and a few individual hydrologic element results. So let's begin by running the trial. The first thing we need to do to run a optimization trial is to select the optimization. So we can do that a few different ways. The first way is to come up here to the compute tab and then select which trial we want. I also have a few simulation runs added to this project, but the two trials that I have are these two right here. I'm going to select simplex test. Once that trial has been selected, I will see simplex text right here, the name of the trial, in the basin model title bar. So I have the basin model name and then the name of the simulation that's been selected. The other way to select a optimization trial is right here in the compute tab of the Watershed Explorer. I'll just go ahead and click on the name of the optimization trial. So I can click on this trial and then it changes. And then same with the simulation runs, it would change up here in the toolbar and then the title bar accordingly. All right, so let's go ahead and select simplex test. Now, before we run the simulation, I just want to point out a few options that I prefer to use, and that is up in the Tools menu. If you click Tools, Program Settings, there's this tab here that says Compute. It's the fourth tab over. And I like to have this Compute All Components, even if unchanged. If you leave that unchecked, then HMS is only going to compute the elements it needs to satisfy the optimization requirements. It won't run elements that haven't changed or elements downstream of the selected location. I like to leave that checked, but if my model gets large enough, I may need to uncheck that. The other one I like to have checked is this third one down, automatically close the progress window when successful. And you'll see what that looks like in just a moment. All right, well, we're ready to run the simulation. There's a few different ways to run the simulation. I think the easiest one, once we have our simulation selected, is to just click this button right here to compute all elements. I should probably mention this is the compute toolbar. So if you don't see this already, go ahead and go view toolbars and then compute right here. It's the third one for me. So that's how to make it disappear as well. So let's go view toolbars compute, and I can probably turn off my spatial results toolbar. Okay. So let's just go ahead and click this button, compute all elements, and then let it run. Right now it's running through the optimization trial. It's computing it, and it's counting up the number of iterations until it reaches a convergence criteria, and it finished at about 28 iterations there. A second way to compute the optimization trial is once you have a trial selected, go ahead and go up to the compute menu, and then this bottom option here says compute trial. That will compute the trial just the same as before. The third way to run the compute is over here in the Watershed Explorer. We can just right click on our simulation run and then click compute. A fourth and bonus way of running the simulation for optimization trial compute is through multiple computes. So what we would do there is we'd come up to the compute menu, click on multiple compute, and then select whatever run we want to compute. By default here, the first compute type, for me at least, is the simulation runs, because I have a few simulation runs already in this project. But I would just change that to optimization trials, check those different trials, and then run compute. Now it's running the first compute right now, and then after that, it's going to be running the second one. So it's finishing up the first compute. Okay, and now it's on to the second one. So that's how to compute an optimization trial in HMS. Next, we want to view the results. So we're going to review the results sort of as a system-wide optimization evaluation first, and then I'm going to look at individual hydrologic elements. All right, so the first thing we're going to do is make sure we have our trial selected. So whichever trial you have selected, that will be the results. that will come up to screen. So with this trial simplex test option selected, I'm going to go up to results. And now we have some results right here: objective function summary, optimized parameters, observed data, and objective function. I can go ahead and select objective function summary. And what I see at the top is information about the simulation run itself. We selected this optimization trial simplex test, the start and end date of the simulation, the Bayesian model, and the meteorologic model. Here we have some information about the optimization itself. The goal was minimization. The statistic was root mean squared error, and then the start and end of the function as well as the value. So this value 392.08 may seem a little bit meaningless, but it is the optimal value that was calculated for the optimization that was performed. If we go back to the components menu and then select, I'm sorry, the compute menu, and then select on simplex test, we now have the information in the objective tab here of the components editor to describe the information that was run for how the simulation was defined, such as it was a minimum simulation using root mean squared error method or statistic, and then with some other information here. We also have three parameters, which I have defined right here with an initial value and then a minimum and a maximum value for the search range. So we'll return to all that in a little bit. But here's the summary table. At the bottom, we have a table that compares the simulated optimal results from the model with the observed data. So here's the observed data right here for the total volume in inches, the peak flow, and the time to peak. So you can see like the time to peak matched up, but we were way under on peak flow and fairly equal on the total volume. It shows the difference in values right here, and then the percent difference in the far right column. I prefer to use acre feet when viewing volumes as well. It just feels a little bit more normal. Right, so we'll go ahead and close that one. The next result we can view is optimized parameters. So what we have here are, there's the three parameters that I pointed out earlier. These parameters are the Mott-Clark time of concentration, the deficit and constant initial deficit, as well as deficit and constant rate of infiltration. Those three parameters are shown in this table right here. We have time of concentration, initial deficit, and then the constant infiltration rate. Our initial values are shown in this penultimate column, and then the optimized values are shown here. As you can see, my initial volume values were way off, and that's just because I didn't put a whole lot of thought into this model of optimization. I was just setting it up to demonstrate the lesson and the results and how that works. Up at the results table, the next one is observed data. So if we bring this to screen and make it a little bit larger, we have three tabs across the top. There's a time series tab, compare tab, and residuals tab. The time series tab basically just shows the data in the comparison between the observed data and the model output. Now for this particular simulation, I selected a location of this Punks outflow location. This is the outlet of the watershed. It is a sink hydrologic element. If I click on the compute tab and then simplex and then objective, I now have the location right here is Mahoney Creek gauge at Punks, which is this gauge right here. If I select this hydrologic element, this gauge, it also needs to have an observed time series data set to compare with the actual output data from the results. More information on how to properly create an optimization trial in HMS can be found in the previous lesson. This is 64, but the previous lesson is 63. So go ahead and check that out if you're unfamiliar with creating an optimization trial in HMS. The data that we have assigned to that outlet can be found in the Options tab, and it's named right here, Puxatawny. So this is a time series data set. And again, this is described in more detail in lesson 63. Okay, let's go back to our observed data. Here is the plot. The blue is, let me zoom in a little bit here. So I'll use the zoom icon and then I just drag the area of interest. Okay, it's a little bit better. How about right there? The blue line here represents the output from the model, and then this black line here is the observed flow. So this is a hydrograph. This is the flow rate vertically in the last 6 days of the simulation, the more interesting days. It's a 14-day simulation, but this is really where all the action takes place. As you can see that the model results right here in blue overestimate during September 10th, underestimate on September 11th, and then again seem to overestimate on the 12th and 13th. Parameter values for this optimization are not a very good fit. We could definitely improve the parameter estimation here, but it's a good first start. The next tab over is the Compare tab. If the computed results are exactly equal to the compared data, the observed data, then the data in this Compared tab here will be an exact equal plot at the 45-degree angle line with the comparison data. Data points before the time of peak are shown in red circles, and data points after the time of peak are shown in blue triangles. So you can see we definitely have some problems with higher flows. Lower flows, we're doing all right, but higher flows, we're definitely off. The last tab here is the residuals tab, and this basically just computes the difference between the two time series data sets on this time series tab. So we have two hydrographs here, and the difference is mostly taking place on the 10th, 11th, and 12th of September. So that's where we see this variation here. Focus in here. Perfect fitting model where parameters exactly match what they should be would result in a residuals line of 0, just a flat line across. But we're seeing quite a bit of difference. We're off by more than 1,000 on the 10th, and then about 2,000 CFS on the 11th. Okay, so that is it for that plot. The next plot up in the results menu is the objective function. So if I select objective function, what we see here is the objective function value that we're trying to minimize. And then it finally converges at evaluation number 58. So it starts off pretty low. It just kind of wiggles around and finally ends up right here. When preparing for this lesson, I noticed that this particular optimization trial here is a maximum. We're maximizing a discharge. And then when I went up to results, I did not see the observed data, even though I do have observed data associated with the outlet sink element. So with the minimization, I did have the observed data. Oh, I also didn't see this earlier. I have the individual parameter plots as well. So we have three parameters in our model, 1, 2, and 3, which are associated with, I could look it up, time of concentration for parameter 1 here over the course of the evaluation period. So you can see that it starts down here at like 16, and then it increases, and it finally finds a value that it's happy with and that it converged at. Similar data is available for the other parameters. Here's parameter 2 plot. And then here is parameter 3 plot. Those are for the percolation rate. And then parameter 2, I believe, was the initial loss. We've been viewing all these results by accessing the results menu up here and then selecting one of these values. But we can also access these same results here in the Watershed Explorer by clicking on this results tab and then expanding out our optimization trials directory and then selecting our optimization trial. You can double click or just click on the plus icon to expand. And then these same 7 options right here are these first 7 icons in the results tab. So for instance, here's the objective function results. Here's the optimized parameter table. Let's go down a little bit. Here's a parameter 1 plot and so on. So it's the exact same data, just a different way to access it. Okay, so we've looked at data for the entire model to assess the optimization and how well the parameter data fits to match the model outputs with the observed data. But now we may want to look at individual elements. So on our basin map, we have a number of hydrologic elements such as the basin, the subbasins, the reach, the outlet, and we have a junction right here. There's multiple ways to view the individual hydrologic elements in the data from the optimization trial in the watershed. The first thing we need to do is actually select an element. So we can do that just by clicking on an element. Here I've selected the Stump Creek Subbasin. And then up here in the Components tab of the Watershed Explorer, it's also selected. We also need to select the optimization trial. So we've already done this by selecting the trial here from this dropdown. After that, we can go up to the results menu and then click on one of 3 different options here to display different data for that individual hydrologic element, such as the element graph, the element summary table, and the element time series table. Let's go ahead and select the element graph first. So what we're seeing here is a hyetograph on top and then a hydrograph down below. The hyetograph shows in blue the total precipitation, and then in red is the precipitation loss. Then down below here, the hydrograph shows the total hydrograph, the total flow, and then in the dashed line here, this is the base flow. The data for this plot here is contained within the results menu and then time series table, which is right here. So let me bring both of them up at the same time. So I got them both up at the same time. The blue series would be the total precipitation. That's this right here. And then the red would be the losses. That's this column right here. We're seeing all zeros right here because this is just for the first day of the simulation. It looks like there's no rain until the beginning of the second day. So if I scroll down a little bit, now we have some non-zero numbers right here, at least. The first 2 a.m. and 3 a.m. on September 2nd is this line right here. Okay, let me scroll back up to the top. The hydrograph down below has its data in these last couple columns. So we have the total flow and then the base flow, and then the difference would be that direct flow. So the excess precipitation and direct flow contribute to the overland flow runoff. All right, let's go ahead and close those. There's one more individual hydrologic element results option here, which is the summary table. So we click on the summary table. We've seen part of this before, which is the top part where we just identify the optimization trial selected, the start and end date time, the basin model, the meteorologic model, and so on. Down below here, we have actual results for that hydrologic element that we selected, such as the peak discharge in CFS from the basin. We also have the time and date of that peak discharge, which is based on a 1 hour time step, I believe. And then below that, we have a number of volumes. So we have precipitation volume, loss, excess, and so on. If you want to see the volumes listed in acre feet instead of inches, you can just click this radio button here and you'll see that conversion. The data that we see in these plots of individual hydrologic elements depends on the type of element itself. So for subbasins, we have a hyetograph and a hydrograph. But if I select a junction right here and then go up to results element graph, I'm only going to be seeing the hydrograph, two of which are inflow from the upstream subbasins, and then one is the total outflow, which would be the sum. Also, here's a reach element. So if I click on reach and then graph element, all I'm seeing is the inflow and the outflow, which is interesting because we have a little bit of lag and attenuation here. The inflow is going to be the dash line right here, and then the outflow to that reach will be the solid line. So we notice that there is a little bit of attenuation and also lag. Lag because it just takes water time to flow downstream, and then attenuation for various reasons such as infiltration, evaporation, as well as the storage as well in the reach. I also wanted to point out if we select multiple elements, so I'm holding down the control key on my keyboard. If I select all three of the subbasins, for instance, it doesn't matter which elements we select, then we can actually open up the results for all three. So if I wanted to open up the graphs for all three at a time, I can do that. And we can just do a visual comparison this way, as well as the other options. So if I wanted to open up all three tables at the same time, I could do that just the same. I can also highlight multiple hydrologic elements in a basin just by holding down control and then clicking over here in the components menu of the Watershed Explorer. There's a few different other ways to view the same data we saw of the optimization trial results for individual hydrologic elements. The data will be the same, but there's just different ways to access that data, the tables and the plots. For instance, if we select a hydrologic element from the basin map, we can just go right click and then view results. And our options here are graph, summary table, and time series table. These are the exact same three options that we saw when we clicked results: graph, summary table, and time series table. Third way to access individual results from a hydrologic element is, again, go ahead and select an element. I'll select the reach here. Here in the compute toolbar, we have the same three plots. There's the graph, the summary, and then the time series. So here's the graph, here's the summary table, and then here's the time series. A fourth way to access the same data is over here in the Watershed Explorer. You can go ahead and click on the results tab. And then under the optimization trial, which I've selected as simplex test, we have our individual hydrologic elements right here, which has a lot of data. Graph, summary table, and time series is for the East Branch Mahoney Creek Subbasin. That's this one right here. And then if I close that, like right now, I don't have the plus minus icon for some reason, but if I just click on the name, it appears. So I'm just going to display all the last one is Stump Creek. Yeah, so for Stump Creek, for instance, I can just click on the graph and boom, it opens up. I can click on the summary table, it opens up, and so on. The data you're seeing down here below these first three options are time series data that's been saved to the selected DSS file as a separate time series data set. So we have outflow, cumulative precipitation. You can barely see that one, it's blue and white, canopy overflow, and so on. This data is stored in the DSS file, which is defined up here in the simplex test. Let me click on compute and then simplex test or whatever optimization trial you're dealing with. There's this output DSS file, and it is in my project directory, and then the name of the optimization trial.dss. I'm going to bring up DSS view and then open. Let's go ahead and navigate to that DSS file, simplextest.dss, open. Okay, now we have a number of paths here with saved data. So it looks like here's all the Stump Creek data. I'm reading in part B. Here's Mahoney Creek local subbasin data. And then above that, we've got data for Mahoney Creek. Okay, so this is the reach. And then there's also the junction is named Big Run. DSS View allows us to view the data a little bit differently. For instance, we can look at the outflow for all three subbasins by we could filter part C by flow. So let me go ahead and just type in a filter up here and then enter. So this gives me just the flow parameter for all the data sets. I'm going to highlight just the records that are for subbasins. And I'm going to go up to the plot icon. And this is interesting. We have the plot for the three different subbasins. And what we're seeing is the outflow over the course of this 14-day simulation. In yellow is the Stump Creek subbasin. In red is the local Mahoney Creek subbasin. And then in green is the East Branch Mahoney Creek subbasin. Something is up with the Mahoney Creek subbasin. I'm not going to try to figure it out, but this is the subbasin that's further downstream and may have a lot more base flow. If we want to look at the data that makes up this table, we can just go File, Tabulate, and that way we can see the actual values for the outflow for all three subbasins, and then for each hour of the simulation. All right, well, that was it for this lesson. We talked about running and viewing results for optimization trials. That required selecting an optimization trial, running the results, and then viewing the results either through the results menu up here, the toolbars, or the Watershed Explorer.